Talk about correlation and line of best fit. I'm going to have another follow-up video that kind of models how we write equations based on line of best fit. Um, that will probably come out later today, so sorry about not having that ready in the morning here. All right, so a couple of things we have to go through. First is this idea of what correlation is. So let's go through some vocab first. As always, make sure you're formatting your notes correctly. Correlation, line of best fit at the top. The date that this was recorded is April 14th. The date that we'll be using this in class is the week of 4/19. So just write whatever date you wrote the notes down. That's fine with me. All right, so vocabulary heavy today. Let's get to it. Okay, correlation is a relationship between variables in a scatter plot. Correlation, generally speaking, refers to some sort of linear pattern, whereas association, which you'll see down here, kind of just refers to any relationship between two variables. So today we're talking about as it relates to a linear pattern. Okay, so positive correlation is pretty straightforward. As x increases, y also increases. So if you look here at our example, you kind of see as the dots go up as we go to the right, x is going up, y is going up. In this case, it is the amount of time students have been studying in test scores. We kind of expect a positive correlation there. The next one is negative correlation. This is pretty straightforward too. As x increases, y decreases. So this shows a car value over time. The kids always say, well, Mr. Robinson, my dad has an old Mustang or whatever. Yeah, there's exceptions to every rule, but generally speaking, if you buy your Honda, when you buy it, it's going to be the highest value. 15 years later, it's going to be worth a lot less. So that's generally speaking, you're going to see a negative correlation. As cars get older, the value decreases. No correlations means basically X and Y are not related. There's nothing, they have no connection whatsoever. So in this case, it is the height of a customer and the amount they spend weekly on groceries. That's probably has a little to no correlation. So no correlation is probably your best bet. Okay, line of best fit, we'll talk about that more here in a minute, is a line that approximates the pattern of the data. So for like the positive correlation one, we'd expect a line that's going up, right? For the negative correlation, we'd expect a line that has a negative slope. And for no correlation, there really isn't a logical place to place the line. All right. Now, residual is the distance the prediction is from the actual observed measurement and association. Went ahead and introduce this now. We'll talk about that more on the next video when we're dealing with actually making a line of best fit and then comparing it to the data we actually collected or using, I guess, is a better scenario, better way to state that. So it's just the distance from the prediction as opposed to the actual observed value. The reality is the line of best fit are never perfect. They kind of model what we'd expect, and there's always going to be exceptions. So that's kind of what the residual deals with. All right, let's talk about what a good line of best fit is. So a good line of best fit meets the following parameters. This is pretty straightforward. One, it follows the direction of a pattern, of a linear pattern. So it basically follows the dots. Okay, so your line of best fit will follow the dots on a scatter plot. The second part is you want to have approximately half the dots, approximately half the points above and half the points below. Okay, so I don't want you to fixate on it being exactly 50-50, but basically what that's saying is the line should go in the middle of the dots. Okay, so we have some examples here to look at. So example one, this is not a good example of line of best fit because it's about 50-50, but I mean, the line should be doing something more like this, kind of going in the middle there, right? As opposed to, let me go ahead and actually insert a line. Should be doing something more like that right there, kind of in the middle, as opposed to be going up at that angle. So it's just a little too steep and it starts at the wrong spot. Okay, number two has the right slope, as in its rise over run is about right, but it's a little too low. So if you just shifted this up a little bit, right? So, oh, that's not what I wanted. We just shifted up and put a line more like right there, a little bit better. You notice how I'm not really counting, I'm just kind of eyeballing it. I'm using technology, which makes it easier to move around, but it's approximately 50-50 and it's following the pattern. Okay, three here actually wouldn't work at all because it's not even a linear pattern, it's an inverse variation pattern. So it doesn't really make sense to put a line in there in the first place, right? If it's not linear. Example four is actually a good example of a line of best fit. You notice it's following the pattern of the data and the points are about 50-50. So this is a good example. It's kind of what we'd expect. Example five, right? If you look at that, it's 50-50, but it's not following the pattern of the data. So we'd expect something more. This thing's pretty finicky, but let's see. Something more like, oh, it's not gonna let me do it. All right, you guys get the idea though. It's gonna be going something more like that. Example 6, it's following the pattern, but it's just simply too high. We need to lower it down a little bit. All right, let's talk about correlation, going back to original things. So I'm going to give you some examples. If you think you know, tell it to yourself before I tell you. All right, state the type of correlation. So the shoe size of an individual and their height. Okay, so generally speaking with this one, this would be a positive correlation. As people get taller, their bones kind of grow in proportion. So if you're getting taller, you'd expect your feet to actually get larger as well. So if you get taller, your feet are going to get larger, hence your shoe size will increase. So this is definitely a positive correlation. Okay. Okay, the number of miles an individual runs a week and their resting heart rate. Okay, this one can sometimes be counterintuitive, but if you run often, if you run frequently, if you work out frequently, just have to be running, right, you're going to be in better shape, which means your heart is actually going to pump more blood each time it beats. That means that your heart has to pump less blood, or let me restate that, means it has to pump less times in order to move the same amount of blood. So as you become fitter, right, your heart has to pump less, which means this is going to be a negative correlation. Remember, pause real quick here. This is a good time for me to point out that positive, negative doesn't mean good or bad, right? So for example, you could have a positive correlation like your blood pressure and the amount of cheeseburgers you eat, right? The more cheeseburgers you eat, your blood pressure is going to go up, right? It's a positive correlation, but it's not a good thing, right? So just remember, positive, negative doesn't really have any judgment on whether or not it's good or bad. It's just a statement as to how these two things react to each other, right? So kind of sometimes students get caught up on like, well, I thought running would be a positive thing. It is a positive thing, right? And your lower resting heart rate is also a positive thing, but the correlation between those are negative. So just keep that in mind. All right. Last example I have here is the cost of Peruvian coffee and the number of asteroids currently hurling towards Earth. All right. No correlation. The coffee price could go up to an infinite value or go down to essentially free, and asteroids currently hurling towards Earth and our impending death and destruction are unrelated. All right, so let's keep that in mind. This would be a no correlation, so I usually say NC, no correlation. All right, now what I want you to do is go ahead and think of a couple examples of each and be ready to share them with me when we're in class next week. So I'm going to hurl it out. We usually have some fun with this. So if you guys can think of examples of positive correlation, negative correlation, no correlation are usually the most entertaining. So kind of think of a few to share with myself, Miss Olson, or Mr. Martz next week. All right, now let's talk about line of best fit. So what we're going to do is we're going to quickly plot these points, and we're going to go ahead and insert a line of best fit. The next video I do, we're going to do the same thing, but we're also going to add a equation. We're going to do it two different ways, but right now we're just worrying about kind of putting a line in there. Okay, so plot the point. So 1, 3. Okay, and then 3, 3. If you have overlapping points, don't worry about graphing it twice. It's fine. Computer models will factor that in. It's kind of hard to factor that in with a model we're doing by hand. Okay, 8, 8. Then I have 4, 5. Might be a good idea to check them off as I go here. So if you didn't bust out the graph paper to do this, that's fine. Just follow along and just make sure you kind of see what I'm doing here. 5, 5. 4, 6. 2, 4. So quick reminder, the first value, X, says how far we're going to the right. The other one says how far we're going up. And then 6, 6. And then finally 7, 8. 7, 8. So now if we're just looking at the general pattern of these dots, we can make the statement as X goes up, generally speaking, Y goes up. I mean, there's always exceptions. Don't fixate on the exception, kind of fixate on the rule. It's a thing in society to kind of, always fixate on the thing that makes the rule not true when the rule is usually correct. All right, so I'm going to go ahead and insert a line of best fit in here, right? What I think it is, and we can play with a little bit. Now, I want to keep in mind, guys, that your line of best fit might be slightly different than mine, and that's fine, right? A computer model will, generally speaking, give you something that's exactly the same, But as long as you're kind of following that general technique, it's going to look pretty good. So I feel like I maybe need to drop this down a touch, right? And then maybe raise it up. So slightly changing of the angle. All right, now I'm expecting everyone to have something similar to that, right? If you're doing this on your own, right? But I don't expect them to be exactly the same, right? So keep that in mind. That's kind of my expectation, is that they're similar but not the same. Because really we're using an eyeball technique to do this. We're kind of looking at it and guessing where the line would go. Now, there's a technique we used to teach called cue points, which actually gave you a algorithm to do this, which was a little more precise. But the reality is oftentimes when you use that technique, you're not getting a line of best fit that's better than just looking at it and inserting one based on what you're seeing. Next video, we'll talk about another way of making these that's a little more reliable, and then we'll actually kind of try to figure out or derive an equation based on those lines of best fit. So for right now, short and sweet. Remember, this is what we're doing next week, 419, so please watch these videos and hopefully taking notes before class. All right, have a good one. Bye.